Assalamualaikum warahmatullahi wabarakatuh. We are from Group 1. So we are given the task to find about the gas chromatography. So from our discussion, we have decided to choose gas chromatography applications in petroleum hydrocarbon fluids. Okay, our group consists of 7 members. So the first presenter will be Nur Atika binti Sukri. The second presenter is Aina Najwa binti Zainuddin. The third presenter is Muhammad Syafiq bin Maskaza. Fourth presenter is Nur Mazlina binti Osman. The fifth presenter is Wilbur Wong Siu Miu. Sixth presenter is Muhammad Shamil bin Ruslan. And the last presenter is me, is Aida Aini binti Mazlan. Okay, now without wasting our time, so let's get started with the first presenter.
Assalamualaikum warahmatullahi wabarakatuh. I am Noratika binti Sukari and today I'm going to introduce about gas chromatography. In early 1990s, gas chromatography was discovered as a separation technique to separate compounds. Liquid-solid column chromatography is often to use separate organic compound, while gas-liquid chromatography is the most commonly method used to separate organic compounds, but limited application in the laboratory. It's rarely used due to severe peak tiling and semi-permanent retention of polar compound within the column. The purpose of this project is to provide better understanding on its operation and measurement technique and its application. Thus, we have been decided to use gas chromatography application in petroleum hydrocarbon fluid. The advantages of gas chromatography is high column efficiency, fast analysis speed, easy to be combined with other analytical methods, and high sensitivity. With these advantages, gas chromatography gives a better result to be analyzed. Gases are occur from lighter hydrocarbon and inorganic compound, while heavier compound are in the form of solid or liquid under surface and temperature condition.
Hi, my name is Aina Najwa binti Zainuddin. I'm the second presenter. Today I would like to present about features in gas chromatography. In gas chromatography, we use a 2D GC oven, and in this oven, we have 4 components, which is a modulator, capillary column, injector, and detector. So, I would like to describe about injector. So we are going to injector. The function of injector is to heated zone where the sample is introduced via syringe. Injection method where we use a micro syringe to inject the sample through a rubber septum into a flash vaporizer pot at the head of the column. Okay, injector have a 2 mode with a split and splitless. Okay, now it's about detector. Detector is able of creating on electronic signal whenever the presence of a compound is detected. Detector have 3 types, which is flame ionization detection (FID), electron capture detector (ECD), phosphorus detector (MPD). Okay, into the GC oven, we use the flame ionization detection (FID) because this detector is perfect and suitable for this oven. Now about modulator. The function of modulator to convert the peak imaging from the first column into a series of narrow pulses suitable to further separation in the second column. Lastly, about capillary column. Capillary column is located an oven that can be programmed to increase the temperature gradually that help in separation. Okay, the characteristic of capillary column is strength, flexibility, and low reactivity. Okay, in capillary column, we have two column, which is a first column and second column. First column we know as primary column, located in the main GC oven, and the second column located in an independent oven within the main oven.
Assalamualaikum warahmatullahi wabarakatuh and good day. Today I am Muhammad Syafiq bin Masaza. We present about the working principle of gas chromatography application in petroleum hydrocarbon fluids. Okay, let's go to the general overview. For the general overview, gas chromatography is one of the various methods that we use to analyze hydrocarbon mixtures. It is used in laboratory, in permanently installed online system, and in field with portable system. It usually consists of sample handling system, electronic controllers, and chromatograph oven.
GC working principle briefly. The sample gas will be taken from the process pipeline through GC sampling system. A carrier gas, generally helium, will be used to carry out the collected sample gas through the GC column. The GC column will be maintained at a standard temperature, 85 deg C, changes from vendor to vendor, with the heater. The sample gas will be heated for a certain time in the column, so that all components in the sample gas will be separated in the column. The separated components will travel from column to the detector individually. The detector will detect the respective component voltage. Thus finally we measure all individual components in the sample gas. We plot all measured components in a graph called chromatogram.
Okay, for the video, let's take a look at it, where it will be explained by the person inside it. Okay, this is the general overview or the pictures how or what is the gas chromatograph working system. As I mentioned earlier, it consists of sample system, chromatograph oven, and also GC controller. For the sample handling system, it is the system that controls the sample pressure and maintain the composition of the gas. The sample injector that injected to the analyzer must be dry and free from any solids that present in the sample, and also the pressure of the sample needs to be different from the origin of the source itself when being injected to the analyzer. Another function of the sample handling system is to stream selection on multi-stream application, and usually performed by simple solenoid valves. The pressure of the sample needs to be maintained within 100 and 200 until 200 kilopascal gauge. If low pressure, the Thomson effect will occur through the system, which is within the sample system. Other purpose of sample handling system is to maintaining the composition of the gas. It's also to remove the solid particles down to 2 microns. Inlet filters are more suitable to be used. The lag time between the sample enters the probe and enters the gas chromatograph is longer as the volume inside the sample handling system is larger. The liquids are removed using specially designed membrane filters that only gas to pass through it. The next component is the chromatograph oven. The chromatograph oven is attachment of the detectors and chromatograph columns that are vulnerable to the changes in temperature. The oven is specifically designed to isolate the components from the effect of ambient temperature changes. It's also designed to maintain stable temperature internally. Okay, the next component is chromatograph columns. Chromatograph columns are important part for the gas chromatograph. The columns separate into individual components that contain within the gas mixture by using physical characteristic. Chromatograph column is built by pairing a tube with column packing material that are held by sintered metal filters at either end of the tube. The packing material contains small support material that has very thin coating of liquid solvent. Helium is usually used for hydrocarbon applications. However, other inert and stable gases such as argon, hydrogen gas, and nitrogen gas are also being used. The components that have lower boiling points usually move slower than the components that has higher boiling point as the gas sample move throughout the column. The temperature of the column determines the speed of the separation that occurred. Analysis valve. Analysis valve comes in low internal volume, either 6 port or 10 port configurations. The purpose of such low internal volume is for allowing precise switching between components when leaving the columns and to avoid any dead volume. There are two types of methods that being used for the column switching methods, which are backflush and also the dual column arrangement. Individually measured components from heavy components are separated and sent to the detectors as a single peak. Before any of the backflush components leave the column, the sample is pushed through the backflush column until the last of the lighter components has left the backflush valve. The backflush valve is then actuated. The movement of carrier gas through the column is reversed for the heavy components recombined into a single peak. Dual column technique, it will analyze valve switches to the flow path between the column to separate all individual components. The dual column valve is switched when all the lighter components have entered and trapped the components. The flow of carrier gas and sample components is then switched to the second column. After all the components being separated by the previous column gone through detector, the dual column valve is then actuated. Okay, for the detectors are several. There are several detectors that being used for GC, such as thermal conductivity detector and flame photometric detectors. But the most suitable detectors that choose for hydrocarbon gas measurement is flame ionization detectors or FID. Among of its special attributes are greater unit carbon response and has wider linear operating range. Reasons for the use of FID is its low cost, ruggedness, speed of response, and easy to use. FID unit carbon is responding linearly to the mass of carbon flowing through the detector. The attribute of carbon response will allow one to assess mixture without having calibration standards for each of the components. The relative amount in a sample is closely reflected by the relative ratio of the area of one peak to another. This helps when assuming the concentration level of components in a sample that have maybe unknown identities or unavailable for calibration. Most of the manufacturers usually suggested ratios of 10 to 1 or more air or hydrogen flows to achieve widest dynamic range possible with FID. More flame gas will require for prevention of blowout and carbon formation. All cations are collected by a negatively biased collector that will cause current to flow and then electronically amplified. The current is proportional to the number of ions collected and electrons in the flame flow in the opposite direction.
Hi, Assalamualaikum. My name is Norma Zainab binti Osman. Today I will present to you about the function of two-dimensional gas chromatography. Two-dimensional gas chromatography was used to analyze the composition of gas and liquid in a substance. It generates structure of two-dimensional chromatograms. It is a chemical analysis instrument for separating chemicals in a complex sample. An example of a complex sample is such as oil. Oil was made up of three compounds, that is hydrocarbon compound, non-hydrocarbon but still organic compound, and organometallic compound. Which this two-dimensional gas chromatography is offer increased peak capacity, higher sensitivity, and improved resolution. So with this two-dimensional gas chromatograph, we can get the accurate percentage of each compound in a substance. Okay, that's all from me. Thank you.
Hi everyone, my name is Won Soo Mew. I'm fifth presenter in this group. Now I'm going to talk about the sample tested for gas chromatography. Based on our topic, the fluids are referring either liquid or gases. In this case, we use liquid as the sample tested, which is waste crude oil. Waste crude oil is one of the petroleum hydrocarbon fluids. By using GC, or to be specific, we are using high temperature gas chromatography, which is HTGC. In this step, we move to use HTGC method. We can identify the distribution of any molecule in waste crude oil, and imperative use of HTGC to waste crude is the measurement of high molecule weight hydrocarbon to deliver geochemical data and also some essential discovery. Actually, this research is taken from other journal. According to this article related to this topic, HTGC investigation of crude waste samples that block oils well, and also initiate that waste pressure usually consisted of hydrocarbon with carbon meters up to about 40 to 50. A long HTGC process was used to regulate the composition of crude oil as well as solid waste to produce C60 in the Trans-Alaska tube. The vessel pilot is used to reach high revolution with great carbon amount. The proportion of N-alkanes or N-paraffin is used to differentiate among different forms of solid crude products. Thus, by using this method, we can assess and monitor crude oil biodegradation better. For example, using quantitative HTGC methods, biodegradation of aliphatic part of waste oil was estimated. Like hydrocarbon were rapidly biodegraded and HNWHC was resistant toward biodegradation. HTDC also will reveal unlike essential conformation of this HMWHC, the HMWC fraction of the entire oil was considerably greater than conventional thought. The distribution of extensive chain, branch chain, and glycohexane distribution of HMWHC investigated by HTGC has been used as a variable device to differentiate between variable oil sources.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syamil bin Roslan. I will present about example of data analysis. Example of data analysis. The sample test that we use for data analysis is wax cure oil. Oil wax is used for producing the wax-based product because it has a low concentration of sulfur and metals. The method of HTGC is used because it is good in measuring the total and the type of molecule present in the crude oil, so that the data collected by using this method is more effective and good for analyzing a candle compared to conventional GC. So, I will explain about three parts of example of data analysis. The first part is data visualization, the second part is data processing, and the last part is data analysis. The first part is data visualization. In this study, the chromatogram used two methods, which are HTGC and 2D-GC. Most of HTGC data is visualized in 1D version. For 2D-GC, it is visualized in traditional 1D version. For 2D version is contour plot and 3D image is surface plot. The figure of 2D-GC contour plot shows about the advantage of 2D-GC structure. So it clearly shows that there are a variety of groups in 2D parts. The second part is data processing. For data processing, there are two different software. The first software is data acquisition. The second software is data processing. It can conclude that the two of data was designed to control the GC commercial available this major GC 12MS system. Besides that, it also to control the GC commercially available thermoelectron GC system capable of detecting fire and ionization. Finally, it also capable of processing a variety of data and visual capabilities. The third part is data analysis. The data is analyzed based on the experiment that have been done on wax cure oil by using HTGC. First, look at figure 1. It shows the HTGC trace of a waxy crude oil. The trace is visualized here in graph, from which the difference of peak is shown. Second, look at another graph at figure 2. It shows that the distribution of N-paraffin in graph formed for a waxy crude oil that have been analyzed by using HTGC method. In this case, we can see clearly that when the weight percent of N-paraffin in crude decreases, the carbon number also decreases. Another advantage when we are using HTGC is we can study the origin and some of source crude oil can be analyzed. All models of experimental data relate to the distribution of N-paraffin, which is now available from HTGC. From what have been stated by Zhou and Zhang in article, they have developed a model to predict wax appearance temperature base oil composition that has been given by HTDC. In this case, we highlight three parameters in improving the distribution of paraffin that have been mentioned above. The last figure is figure 6 that shows about contour plot diagram from polar to non-polar column. The contour plot shows that the sample was separate according to specified parts, namely part 1 and part 2. So the choice is dependent on the polar stationary column at room temperature, column length and diameter, Sumatra also fault environment. The figure also shows that the non-polar configuration to configure reverse polarity established from improving resolution branch individual as alkana, alkane and cyclocane. From the observation that have been made, the situation is normal configuration that looks like an upside down. So the conclusion that can be made is that the shorter the period of detention time, increasingly more compound that are at the poles. Thank you.
Okay, last but not least, it's me, Aida Ayuni binti Mazlan, will conclude all about the application of GC in petroleum hydrocarbon fluids. So the first point, gas chromatography is an important method in the analysis of petroleum hydrocarbon. So from the start, we are introducing you on how the GC can be found. Then we will introduce the features in GC as well as its operation principle. The second point is we state about the GC system is easy to use because the operation is much clearer to be followed. Because the harder part to understand is when GC is introducing us to several methods in order to analyze the data. Because in analyzing the data, they are using two software and to maintain it, which is HTGC and 2DGC. So for the software, they are using data acquisition and data processing. So these software are able to control GC, which is in the end they are helping in producing a good visualization data. So the fifth point is that 2D GC technique is very young in this field compared to GC. So the researcher believe that with the advanced research of work, they can produce more precise composition in broader range compared now and also give more important geochemical information of this petroleum fluid in the near future. So we will recommend the research on this phase should be continued because it is really important to know details on the composition in the petroleum fluids. Because we all know that the petroleum is a sustainable source. So because of that, by knowing the details on its composition, we can use the molecules from the source much better and no will be wasted even one. So before forgetting, we would like to thank our lecturer because giving us a chance to do this report. Even it is hard at first, but finally with our teamwork and advices given, we made it last. So this study stimulated us to know much more application in the industry that might help us better to relate from what we have learned in the class with the real situation I saw. So that's all from us. Thank you.